Hello everyone. So today I would like to talk about this article I found some time ago about plasmas, which is kind of a thing in the computer graphics world, but it is just mixing some sine waves in different shapes. It doesn't not necessarily need to be stripes. It can be circles or other shapes into the mix, but certainly, there's a sine wave tendency in these kind of patterns, like the ones we are watching actually in the article. And I found this article pretty interesting because besides the math, it has these animations that just with watching them and reading, a little bit of what the author wrote, we can actually get pretty much the same um, results. So I think it's pretty interesting thing or practice to try to doing this in Vsynth. So I thought about sharing this with you. If you want more inspiration regarding on plasmas, you can check in Shader Toy plasmas. There are some really interesting ones that, again, you can also try to make with Vsynth. This is one of the first that appears in the search. And as you can see here, there are some triangle waves, there's not just sine waves. So it adds another flavor in the color mix. Um, then we have this one, which is similar to the one we are creating, which you can kind of distinguish the center of a radial waveform generator, like moving around here. And it's pretty similar to the one we are creating today, actually. Then we have this one. I mean, you can mix. Here I see some frequency modulation maybe. So as you can see, there's different ways to get the pattern of the plasma, but mostly it is with sine waves and then just using the same sine waves to make the color. Here's another one with a totally different shape and totally different way to create it, I think. This one is more stripy and maybe some frequency modulation here also. So as you can see, there are different kind of ways of achieving a kind of cool plasma. Yeah, and this kind of pattern might be considered plasma as well. So so let's see the one that we are going to create. This was made for, I think, a demo, an intro screen for a demo or something like that. And wow, so it is pretty much mixing three sine waves. One is going one. The first one is a vertical sine wave going to the left. The second one is a rotating sine wave, and also I can see some frequency modulation there. And the third one is a radial waveform generator, making some, moving the center around in some kind of Lisa juice figure. So yeah, so that's the three sine waves the author of the article is mixing here, and here's the result. And we can also see that the three sine waves are average in the sum, because if you add actually the three together, we are gonna get burned, uh, a burned image. So let's try to make this in Vsynth. It's kind of straightforward, I think. So it's just mixing three different sine waves together. So let's start with the first one. Create a new batch. And as you can see, the first one, we already actually almost have it working. The differences are that it is scrolling slowly to the left, and it's it has a cycle and a half. Okay, so let's make this a cycle and a half, maybe 100 hertz. Let's just slow down its motion and toggle the invert direction. Okay, so there we are, and we have our first sine wave from this plasma. And since we have to add the different waveforms together, let's just grab a mixer 3. Well, so the second animation, it's more tricky because it's actually rotating and the frequency it's added from the center. So one way to do this is with the bipolar waveform generator that actually do exactly this. So since the bipolar waveform generator also splits the brightness between -1 and 1, we have to here toggle the polar brightness. So it goes from 0 to 1 and it behaves exactly like the waveform generator 2 and 3 and the others. But the cool thing about the bipolar is that the frequency it's added from the center and the rotation it's also happened from the center. So this is gonna be pretty useful to get the second pattern working. Alright, so for the frequency modulation, we can just modulate the frequency with an LFO. And for the rotation, we can use the data output from an LFO to externally control with a message the angle parameter of the bipolar waveform generator. So let's grab some LFOs, two LFOs for now. Let's grab the texture output from one of them and send it to the frequency modulation input. Yeah. And let's make it a little bit less. The speed was too much. Well, cool. And let's change the LFO. I think the animation was kind of a triangular. Yeah, let's make it triangular. Awesome. And for the rotation, let's use a ramp and make an infinite rotation. And for that, I'm gonna multiply the output, the data output from the LFO that goes from 0 to 1 by 360. So it goes now from 0 to 360. I'm sorry, the data output. And then just prepend angle here and send it to the control input, which is also the first input. And let's make this less fast. Awesome. So this is how it looks, the both of them mixed together. As you can see, the colors are burned, and we actually have to make this like 0.5 to make the average image and kind of get closer of the third image here, which is the result of the mixing of these three different sine wave patterns. So the third one, as you can see in the article, it says that we can also animate and move the center point around in a least adjust figure. So let's just do this. I mean, This is actually just grabbing radial waveform generator, and as you can see, we already at least have the circle. Let's just stop it for a bit and increase its frequency. Let's see how many cycles. It's 2 cycles. And we have a snippet here which actually controls the center of the radial waveform generator. So let's just grab it and let's plug it to the control inlet of the radial waveform generator. As you can see, we can control here. So it should be something like this. And now we have to automate the control of this slider basically, and we can actually grab the output. We can just make a pack here with two values, x and y, and we can send the data output from one LFO here, and let's just make another triangle LFO to control the y. And now we have our radial waveform generator moving with some least adjust figures. Let's just make it move and also invert the direction. So it looks, I think it looks pretty similar. It's kind of fast. Yeah, it's a bit faster. And let's see how it looks when we mix the three. And it looks something like this. And as you can see, it's not the same, but it's pretty similar to the fourth image here, which is the result of mixing the three patterns the author is using. So I think we are in a good way here, in a good direction. We can make a different mix and just increase the brightness of one a little bit maybe, just to give it more character. I think the author is also doing something like that. But if you want to use the average of the three, instead of the mixer, you can also use the average mixer, which actually needs three inputs to work. And it, of course, spits the average of the three video, the three textures you send it to it. So it's pretty handy, this module also in this scenario. But I would like to increase a little bit brightness in the second channel here to give it a little bit more character. So I think we are really good here. We actually made a shape which is similar to the one the author is getting. Maybe we can increase here a little bit the frequency and it also looks better. Yeah, I think we are getting something pretty similar, which is okay, which is great. I mean, also expected. And let's see what the author is doing with color, because it's doing something different, and what you can achieve like instantaneously with Vsynth, because it's kind of shaping the final image. I mean, it is applying different curves to the final image and then sending the result of applying those curves to RGB channels, and that's how he's getting the colors. So there's not a straightforward way to do this in Vsynth, because there's no this kind of wave shaping yet, but there are other ways of colorizing, and I'm just thinking of a way of kind of getting some kind of similar colors with a Vizzie module, which is kind of a wave shaper like the author is using here. And then I'm gonna port these formulas into a jit.gl.pix so you can also see how implement your own kind of colorization uh, without a Vizzie module or a Vsynth module. So let's just do one way of colorizing this is to grab a color generator and send it to a hue modulator module. And then we can just displace the colors with the pattern we are getting from the plasma shape here. Let's see what happens. Yeah, we have like really straightforward a rainbow uh, plasma pattern here, and you can change the first color you start displacing with the hue, and you can also here change, for example, color space with the RGB to YUV, and after that you can also rotate hue to access certain palettes from this different color space, and you can get these funky palettes. I really like this kind of combination of colors. Awesome, this looks really good. So another way of colorizing the plasma is to grabbing the 3-band splitter and actually split the brightness of our plasma shape into 3 different bands, then colorizing these bands, and then using a priority mixer to mix these colorized new signals. And as you can see, we have here the different bands of brightness. This is gonna give us a kind of a neon-like pattern. So let me just grab the operator 2 and mix these signals with the max operator. And let's just put some colors. And here you have another way. And as you can see, it's more neon-like. You have this kind of a triangular thing going on. And yeah, so this is another way of getting kind of a different aesthetic and a different kind of plasma look um, with just some extra Vsynth module added after you generate the shape. So I don't know why I didn't start with this way, but you can also use just the duotoner. And if you smooth this, you already get kind of smooth plasma thing with 2 colors, which I kind of, it's cute, kind of like it. You can increase frequency here and get some other shapes, which I guess goes more with the colors I'm using here. And you can also change the duotoner mode to mode 1, and it's going to behave similar to the band splitter we were just using a few minutes ago. So yeah, so here's another way of having another kind of more neon plasma like. Awesome. All right, so another way I think that might work, it's using the Vizzie mapper module, which maps color with these different curves. So now the R channel is it's like applying a sine wave to the red channel, a linear ramp to the green, and this square root shape to the blue channel, and you get this kind of colorization, which is pretty smooth and beautiful. And you can change here the different transference curves, let's just call it that way, and get some other cool colorization mix. And totally adds a different flavor to this mix. So I think that it's kind of cool to also use some Vizzie modules along with Vsynth in this case, which it's working just pretty fine. Here's with another kind of pattern instead of the circle, and as you can see, you get different kind of plasma looks, which is awesome because these are really few modules. I mean, I'm not doing any black magic here. It's just three different oscillators and this color mapper from Vizzie as other way of colorizing, right? So you can actually do this as I show in several ways. And another way is just to try to copy the article. So let me just grab here this because I will need the formulas. And there's something interesting here if you read this, that the author is actually remapping first the brightness values from 0 to 1 to minus 1 1. So that's the first thing we need to do when we start doing this port from these formulas into our own jit.gl.pix shader. So, and also the other thing you need to know is that B here, it is the final image from the plasma shape. I mean, the image we are getting of summing the three sine waves generators. Okay, so I'm gonna grab here the formulas. Awesome. And I'm going to add jit.gl.pix here with Vsynth as render context. And I'm going to plug it after the sum of the waveform generators. And I'm going to erase input 2 and this module, and I'm going to create a pass here. Okay, so as I was saying, the first thing we need to do is to scale the brightness from 0 to 1 to minus 1, 1. And we get more, of course, more blacks. And with this new image is that we are going to make these different transformations. So the final, it's going to be a back 4. So the first thing he's doing to the red channel is to B, which is this is B, it's multiplying B times pi and then applying a sign to all that. So let's just multiply this. Let's just create a box here, which is pi, and then just multiply this by pi, and then let's just apply the sign to all that. So we are going to have that into the red channel. Then the green channel, it's pretty much the same, but instead of the sign, it applies cos. And then blue is 0. And I'm gonna change here again to the radial. Alright, so of course I changed it a little bit and it's not going to be the same, but now we are getting pretty much the same results as the article. Awesome. So next color. Next color is B. I'm sorry. red is 1, green is cos times b times pi, so I think it's exactly this one, and blue is exactly like the one we were using here. Yeah, so now we have the second color here, and as you can see, it matches pretty much what the author is documenting here. So let's go to the third one. So the third one, it's a little bit more trickier, I think. So the first red, it's gonna be the same as we did first. The second one, it's b times pi plus 2 times pi. Okay, so this is gonna be something like 2 pi divided by 3 plus 2 pi divided by 3 plus uh, b times pi, and all that I apply a sine wave, and this goes to the greens. And the blues, it's exactly the same, but it is 2 pi times 2 because it's 4 pi, and it's divided by 3. Yeah, and there we have the third color palette. Awesome. So now we lack just one, which is the black and white. That one is gonna be easy, I think. It is b times 5 times pi. So it's b times pi times 5, and that goes to a sine, and then this goes to the 3R, G, and B to get the white. Yeah, so we get something pretty similar, and yeah, it was just pretty much copying it and taking this into account, this scaling here. But as you can see, you can also use Vsynth to make the shape of the plasma, and then I mean in the case of this article, if you just then copy the formula inside, then in another jit.gl.pix you get almost the same as the article. So I guess this was informative and useful to you guys, and see you in the next one. Stay tuned.